What if we can lower the power consumption? Imagine I can double your battery life, then you throw away half as much, which is a good thing. Or can we now lower the power enough to do energy harvesting so now your battery will last the entire duration of your product lifetime?
Hello and welcome to another Coffee with Mr. IoT. My name is Robert Schmidt. I'm Deloitte's Chief IoT Technologist and also known as Mr. IoT. Today, my guest on the show is David Su, the CEO of Atmosic. David, how are you? And I'm sorry, did I say the company name right? I sometimes,
yes, that's good. Thanks for the time, Robert, to talk about Atmosic.
So, David, why don't you give a little bit of intro? You have a fascinating background. You've been really in hardware and networking and really wireless for a long time. And what you're doing now isn't just fascinating, but it's also really has a huge impact on our environment. So love to hear your take on that.
Okay. Yeah. So from a company point of view, because a lot of us have background in wireless communications, and at the beginning, we joked in a way that we are partially to blame with all these batteries around. So the way we look at it was that years ago, we always have a data cable everywhere we go. You go to a conference room in a new place, everybody fights to use that last Ethernet cable. In those days, plugging the power cord is never a problem. But with wireless communications now, asking people to connect a power cord seems to be so yesterday. So low power devices, as you see, are now all wireless and battery operated. And the next thing you know is that we are just buying more and more batteries. The ongoing joke I have with people around here is that when you go to Costco, look at how big a pack of battery can you find. They seem to grow. And that's fine. But what happens to the battery when you're done? We throw them away. I know we try to recycle them. And so one of the recent reports says that in the US alone, we are throwing away 3 billion batteries a year. That is 100 per second. So that's a lot of batteries.
We're throwing away 100 batteries a second in the US?
Yes. So it's a real problem. So what can we do about it? And so that's where we got started and say, what if we can lower the power consumption? Imagine I can double your battery life, then you throw away half as much, which is a good thing. Or can we now lower the power enough to do energy harvesting so now your battery will last the entire duration of your product lifetime, forever battery life, or even battery free. So that's how the genesis of something meaningful that we could do, given our background.
So let me make sure I get this. You're telling me that you're creating technology that allows me to take these things that make me look like I'm on Star Trek. They won't need charging anymore. They'll just work without a battery.
Yes and no.
That's a consulting answer. It depends, yes.
Right? Devices around you, over time, things improve. Devices around you depends on how much power you need. If you just look back in time, the amount of power needed to do meaningful things with electronics has been coming down steadily over time. In large part, this is technology scaling and also design techniques. So I remember 20 years ago when we designed our first Bluetooth receiver. This is maybe 25, maybe even longer than that. It's about a watt of power. Today, we can do the same function now in less than 10 milliwatt. So you can see that change now. So the amount of energy needed and then the average energy to do a duty cycle device for IoT, for example, is now down to the 10 microwatt level now. So imagine that. So if you say, I need a watt of energy, you better have a crank and crank it to get the energy. If I say I need a 10 milliwatt, blow on it, you might get 10 milliwatt. So that is the transition happening. So now it depends on what you're trying to do. right? So the earbud in the near term, the power consumption is still on the high side because what drives your ear for you to hear, that power hasn't come down much yet. Innovation will get better. So
I gotta wait another 25 years for them to be batteryless.
Hopefully not, but depends on the innovation.
I got it.
Innovation goes beyond communication now. It now comes down to the speaker driver.
Got it. So what can I power today batteryless?
So the ones that we have demonstrated, we have demonstrated a range of things now. We've demonstrated remote control. I happen to have one here. This is this particular one actually uses a small photovoltaic cell on the top here, and it actually works. And of course, we have a battery compartment that's empty. So remote control is fine. ID badge, you have the NFC type ID badge that gives you distances about, I guess, a couple of centimeters. We now can do the same function about a meter away. So that gives you the added convenience as you go to the door. You no longer need to move your body around if you have it in your back pocket to open the door. It just reaches the door handle, it should open. So that you can do. And keyboard, we have demonstrated that as well. Keyboard and mouse type of application. And we are moving up the food chain in terms of functionality. And my belief is that as you go forward in time, the amount of energy will continue to drop, the efficiency of harvesting continue to improve, and that equilibrium will continue to improve. Hopefully get into your earbud.
I don't know. I just had them here and I thought that looked so silly. So I had to use them as an example. But let me ask you this. You talk about energy harvesting, and I don't quite know what that means. I mean, I think I do, but I just tell us what that is. You know, it's sort of really a weird concept.
It's from the high level, you say it's free, but the truth of the matter is not. Nothing is for free. There's no free lunch easily. There's always a catch, right? So energy harvesting is the concept of getting energy from less traditional sources. We have agreed to as a world that batteries are a legit form of energy. A wall socket is a legit form of energy, and more or less anything else is considered harvesting today. And now, how much is?
So what energy are you harvesting? I mean, I'm assuming you don't have a wind turbine on there, and you're not going to have a solar panel on there. What do you harvest?
Solar panel. Yes, we do.
Okay.
Very small panel. So indoor lighting is a good source, because what happens is that humans like to see. To see, you need light, and so what we aim for essentially is a design that only takes about 200 lux, which happens to be the light needed to read. So you bright enough to read, you can harvest enough energy to run our devices. You always have motion. One of the many common uses is a light switch you have on your wall. You click on it and it turns on. And in our device, that tiny motion of clicking is enough to power the device. Yeah, so you're not actively, you can put a crank and crank it, but that would be a little obvious, the harvest. But it's the click motion. And the other interesting thing, as I alluded to, is RF. RF is used for communication. You can imagine NFC is almost a form of RF harvesting, but we do the long range one in the case that gives you the same type of functionality about a meter away. So we have, and then thermal is a fourth one that we have played with so far.
What's the fourth you said?
Thermal, body heat.
Body heat, got it. Okay.
Yeah, it's a delta of temperature difference between what your body is versus the ambient temperature, which works most of the time unless you happen to be in a very hot environment. Then, So the problem harvesting, maybe I should point out upfront, is that nothing's for free. So there are essentially three equations to harvesting. You can imagine, first, amount of energy you need. The second is amount of energy you can harvest. And if the energy you harvest is greater than this, obviously now you don't need a battery. But if the energy you are harvesting comes and goes, intermittent, which is quite common as well, then for it to work, you now need to have a source of energy storage. So to me, there are three equations to make this work, depending on your condition. If you know for sure it's a door lock, I have a source near the door, no batteries needed. If I know I only need to use my remote with light in the room, then you don't need a battery at all. But clearly that's not the case. So what we end up doing essentially now is we have a supercapacitor inside, a very small capacitor inside that will store the energy. So if you let it sit on your table for a couple of hours a day, you can use it all night long. So you see the three components, yeah.
Got it. So various forms of energy gotta be generated through some form, clicking, like all the stuff around us, which is sort of funny if you think about RF. You're actually telling me you need less energy. Does that also probably mean the devices are sending less energy? So you're gonna have more devices needed to fill it. And then you have you have light, obviously, that's something. And then you gotta store it, capacitors, like really small ones. So how big is this chip you're talking about?
Chip, okay. I happen to have some here. It actually comes in two sizes for now. They're all kind of small, but I don't know whether you can see them or not. Here is, oh, can you see them? Yeah. This is a 5 millimeter by 5.
Smaller than a fingernail. Okay. And what does that chip do?
So our chip comes in two flavors. One is just lower power consuming communication link. We use Bluetooth standard for this. And the second flavor does the same thing, plus the energy harvesting, the power management needed for it to work. So for example, in this device now, that one chip does essentially everything. You have a few passive external, and we do have a super cap. I think it's like 0.2 farad super cap on here that lets you essentially operate in the dark during the night. Because I don't know about you, I watch TV in the dark. Usually, I don't leave the light on when I watch TV.
Oh, interesting. Yeah. I talk to my TV now, and I don't know. Some people think that's weird.
We do support the function. We do have a push to talk on it too. So.
Oh, cool.
Even with this, you can talk to your TV still. Yeah.
So that chip you showed me, that chip isn't just a Bluetooth chip, though. That chip actually has memory and has a processor on it, right?
Correct. Yeah. So Bluetooth is one piece of it. It has a processor. It has memory subsystem all associated with it. It has a sensor hub device, and it has power management and an RF harvester. So there are several pieces to it, and I can try to maybe wave my hand around it. So if you look at energy consumption, the Bluetooth radio consumes, in this case, the largest sector of the energy, even though ours is much lower than everybody else out there, but still the largest. And then the MCU MCU memory subsystem is quite a bit lower. And then we add in the sensor hub device that is dramatically lower. So you get these tiers of energy consumption, and we build in the state machine to allow you to shut off different pieces of it so that you can save energy as well. So from a system point of view. And then there is a power management in it.
So what device do I maybe own today, or someone out there would own, that has your chip in it today?
Since we are just launching it in the later part of this year only so far, so you probably don't have anything in your home yet. We are hoping to change it next year.
Okay.
So
what will I have in my home?
So we are looking at a fairly broad range of products right now, from a beacon device for tracking to HID devices and remote control devices as well. So there's a fairly large portfolio of products that we're bringing out that will have our product in there.
Very cool. So you're the CEO of the company. You started this how long ago?
This is now coming up to 4 years. Yes, it takes a while to build this little.
Oh no doubt. Holy smoke. So I'm curious, what's the hardest thing about this? What's the thing that was really hard, and maybe the hardest thing that you didn't expect in this whole journey? I'm always fascinated by journeys like this, right? Because you sit there 4 years ago, and you got to forecast, you got to think what's out there, and then you have a lot of experience in this from before, and so you have some theories around it. But what were the hardest things that you found along the journey?
I would start by saying that the hardest part of it actually is getting started. It almost requires some level of temporary insanity to actually commit to doing something like this. So I'm very fortunate in the sense that we have co-founders together that you felt like you're in it together, working with old friends. So that makes that leap of faith much easier. So to me, that is in my mind the hardest part of it. And once the wheel starts turning, then it's not that different than going to work every day. The only difference is that you felt like if anything goes wrong, you can't blame someone else. We are the ones to blame. And in many ways, it's very rewarding. In some ways, a little scary. That's why I mentioned the first part of it is that in many cases, it does take some temporary insanity to commit to doing something like this. But as you know, people join startup companies on a regular basis in the sense that it's definitely gives you much more influence over the organization. It's a smaller organization, much more agile. And in many cases, you find the environment that you work with, the people that you work with, all having the same notion of what success means. And that is the fun part of it. And according to one of my co-founders, who happens to be behind this wall, he was saying that in life, it's always important to look back what you've done. Have you spent your time wisely? So that is one thing in the sense that, are we doing something that can be impactful, hopefully moving the industry in the right direction? So looking back, that will be very satisfying to see what we do help influence the world in the right direction.
Yeah, I mean, reducing 100 batteries a second that get thrown away through this is obviously super, super interesting.
We hope they'll be meaningful. Yes, correct. Exactly.
When the thing is, right, I don't think that's actually the end of it, right? We're talking about what happens today. And that's not any new sensors that come out. If we think about sticking this on
everything
consumer
else,
products, on everything now, right?
Yeah.
We're going to throw a lot more batteries, or we will throw a lot more batteries in. So you're actually enabling waste growth even in that sense. So very interesting.
Exactly.
So what's the cost of something like this? I mean, I'm curious because obviously we have chips today that with location tracking, they cost anywhere from, I don't know, $5 up. There's some RFID passive tags that obviously aren't as smart as yours that cost much less. But this would be sort of a true breakthrough. What's the cost of something like this? What are you aiming for, I guess?
So we are aiming for essentially is that this is a semiconductor business. So we are aiming to be on par with what you find on the marketplace so that the cost of ownership at the end of the day is no higher. That's the goal. So which means that.
What does that mean? Is that $1? Is that 10 cents? Is that free because the software? I am kind of curious.
Yeah. So for example, in getting into a remote control, for example, the end user cost should not be significantly different. You should not see more than 10% delta, for example. So to you, it should be almost. The idea behind it is the cost of ownership will be lower in the long term and better for the environment, and you might have to pay marginally more a little bit. Unlike that of the LED light bulb, right? LED light bulb, you can see the transition over the last 10 years. I hope all of us have now converted to a more efficient LED light bulb now, but the cost is higher. You can see almost 2x delta in that case. We're definitely nowhere near that. It should be at most marginally more. The low power consumption version, we are actually bringing out at the same cost as the existing solution. So you can easily get the 2 times battery life without paying more. And then for the energy harvesting side, it does cost you marginally more. And in the overall scheme of things, it should not be noticeable to the end consumer.
So this isn't a throwaway device then? You don't see this being on stickers or something that I throw away because it's too expensive for that, or do you?
Depends on the volume. Once again, the whole business premise is volume drives cost. If the volume is high enough, the cost will come down low enough. Depends on, obviously, the cost of a product itself, right? So if you are doing something like a pharmaceutical one, so I know there's a group talking to us now. Since they are dealing with drugs, they want to measure temperature during shipment. For those applications, yeah, that one is one use. And they say the value proposition is high enough for them.
So that thing will measure temperature too?
We do have the hooks because these got the MCU and sensor hub attached. So you can measure, you can connect different sensors to a temperature and various other things along with that. Yeah.
So I got to ask you a question that I often like to ask CEOs that work in tech space, and it's more of a personal question. You work with tech that's, for many of us, probably like, it sounds like it's 5 years out. For some things, it's probably next year, which is fantastic. But what does your home look like? What do you do at home? What are the things at home that I would love to have? Sort of like, give me some sort of view of what does your home look like? Smart home? I don't know. Do you have like, are all batteries batteryless? What does a home of a David Su, the CEO of a tech company, look like?
You'd be very disappointed. I'm a boring person, and I probably end up spending more time here than elsewhere.
Okay, I see what you're saying. Okay.
So to be honest, to be truly honest, I have very limited high-tech gear in my house. So you can see that I'm surrounded by it here everywhere I look, but at home tend to be a little different. So
interesting, yeah. Interesting. Do you miss it when you go home then, or are you kind of like happy to get away from it?
No, I'm used to it. Once I'm home, and except lately, as you all know, with all this current COVID situation, the one thing I do miss is that my day now blends into. Used to be there's more of a partition between work and home, and now they are a continuum. But yeah.
Yeah, it's sort of hard to separate out life from work, right? Because work is so close to life or home that it's sort of like, oh yeah, hang on, let me get the call, and then you step in and you then must step out. So
right, and you used to be at least a lot of your meeting and discussions in person, and now it could be equally likely to be just online as well. So
got it. That makes sense. Well, very cool. I'm super fascinated. I have to tell you, I'm impressed. We in German say "Hut ab," which means take my hat off for you on doing something that's both technology-wise super interesting, but actually helps the environment in such an amazing way around batteries. Because you're right, we have too many batteries. Anything I didn't ask you that we should talk about before we end our coffee chat?
Sure. I actually want to highlight one thing about the current situation of COVID situation. In that sense of contact tracing is now an important discussion around, and many jurisdictions now around the world is beginning to do that. And that's one area I think by using a long battery life solution can allow us to have wearable solutions that will track each other in the event that we get exposed, so we can be notified. So that one I find a very meaningful use cases, and so it's the beginning of that journey, and we are working closely with Google and Apple locally and see what we can do together. So I just want to point that out. That one I think is an interesting application, and hoping that all your viewers stay safe, and we'll get through this. It will be better at some point in time.
Yeah, thank you. I appreciate the positive thinking. I have to do that too here and there, and I appreciate the work you do. And thanks for joining me on this coffee chat. And with that, we have come to another end of another coffee with Mr. IoT. Thank you for watching. If you missed any of today's show or previous shows, check out our playlist on YouTube, or find your favorite podcast, and you'll find our recordings there too. And with that, thank you, David. Thank you for what you do, and I'll see you next time out there when I stop by, and we're going to do contact tracing. You're going to know when I walk in, because you're going to hear before you see me.
All right, talk to you soon.
Thank you so much.